Good morning, everyone. This is Teacher Jonathan, and I'd like to welcome you all in our virtual presentation. And today we're going to talk about mixture and solutions. So let's take a look at this. I hope you find this video useful, especially for my M2 students who are with me in my English science class. All right, let's get started. So let's have a quick review of what mixture is. All right. So when we say mixture, it's made of two or more types of atoms that are not chemically combined together. We are talking about um, on the chemical level here. Okay. So I'm going to use these pictures to explain myself. All right. So showing that these are all chemicals of different shapes and sizes and colors. So basically, we cannot combine these together. All right. So these are all chemicals, atoms, and these are all another atoms, and these are all another one. And technically, you cannot combine them together. It's either they are in solids, they are in liquids, or they are in gas or gases. So any combination of solids, liquids, and gases. Mixture of solids. So um, basically, you have different points in here, and you cannot mix them, right? Just like these pictures right here. And so is the same with the mixture of liquids and mixture of gases. Okay. Now, there are two types of mixtures, and they are heterogeneous and homogeneous mixture. So when you say heterogeneous, these are different, basically different. It means different. You can see the different parts or phases of the mixture easily. When you say homogeneous, you cannot see the different parts of the mixture. So you're basically opposite. A good example of heterogeneous mixture is like this, and the homogeneous mixture are like this. So for example, we have coffee mixed well with sugar and yeah, water. And then you have is this a juice or something? Okay, you can tell which one is which, right? You cannot tell which one is like you cannot separate them. I mean, you cannot say it's water and this one is the liquid part, the juice part. Now, um, well, let's classify them. For example, this one, a cereal mixed with milk, right? Or milk with cereal, that's heterogeneous. A good example of homogeneous is juice, for example, and jelly beans mixed with something else. Let's continue. Now, let's go to solution. What is a solution? This is a special type of mixture. Okay, and when we say solution, it's a homogeneous mixture that combines a solute and solvent. Now that you have two components here, the solute and the solvent. Okay, a solution involves one substance dissolving in another substance, which is usually a liquid. So that's solutions. Okay, and the solid part, solute. When we say solid, that's the solid part that gets dissolved. So, for example, if you have sugar and water dissolved in water, so the solid part is the sugar or salt. Okay, you call them solute, the solid part. The solvent is the liquid part that does not or does the dissolving. So water is a the universal solvent. And a solution is a homogeneous mixture that combines a solute and a solvent. So if this is the solute, you just mix it with the solvent, water. Okay, that's simple. So it goes like this: solute plus solvent equals solution. Salt added to the water is a salt solution. Now, let's talk about the solubility. So we can measure how easily a solute will dissolve in a certain solvent. And when you say solubility, this is the measure, okay? The measurement is called solubility. We have high and low solubility. For example, the solute dissolves quickly and easily. That's high solubility. For example, salt in water. Low solubility, the solute does not dissolve easily. For example, the sand in water, so it doesn't dissolve at all. So that's low solubility. We have many more examples, of course, but that's the best one. Now, when we are studying solution, there are things that we need to understand, and that one is dilute and concentrated. Okay, so for this one, I would like to use an example which is very common in Thailand. If you are familiar with the Hale Blue Boy, are you familiar with that? It comes with blue, it comes with red, and it's very common in red. Sometimes we call it namdeng, right? Do you drink that Hale Blue Boy straight from the bottle? Of course not, right? Because it's too sweet. That's too sweet. And that is what we call concentrated. Okay, we do not drink Hale Blue Boy straight from the bottle because it's too sweet. That's concentrated. And to be able to drink that, you have to get some water or cold water added with a lot of ice, and then you pour in a little bit of Hale Blue Boy, and then you can, yeah, you stir it, mix it thoroughly, and then you can have what we call dilute. All right, now that you can drink and enjoy, right? That's namdeng in ice and a lot of cold water. That is dilution. Okay, we can add a little or a lot of solute. So, for example, a solution with only a small amount of salt is called dilute solution. So, for this example, uh, this one is a large amount of solute. We call it concentrated. Okay. And if you have another word to learn is saturated. So eventually a solvent can't hold anymore. You call that a saturated solution cannot hold any more solute at a certain temperature. So if you add more and more and more into this cup, you call that saturated solution. And there's another term that we need to understand, the super saturated. Previously, we had several spoonful, right? But if you have added another set, you call that super saturated. And you're gonna need to put this in the fire in order to dissolve. All right. In Thailand, we have a lot of kanum made in sugar. And to be able to make that kanum, you have to dissolve sugar like you're making a syrup already. And that is super saturated. I hope that that example helps a lot to understand. And yeah, if you have any more question, um, there are things that we need to understand, especially the vocabulary for this lesson. And I'll be happy if you have any more questions, okay? You can keep your questions, and then when we see each other in person inside the classroom, then I can address all of your inquiry, okay? So for now, I would like you to watch this video about how to solve the concentration of solution. Here we go.
This video, you should be able to calculate the concentration of a solution in grams per decimeter cubed. Higher tier students should also be able to explain how the mass of the solute and the volume of the solution affect the concentration. So let's start by looking at what's meant by concentration. The concentration tells us the mass of a solute in a given volume of solution. Now, I should point out that if you're a higher tier student, you learn another definition of concentration as well as this one in a later video. But if you're doing foundation, then you only need to learn this definition. So what's meant by a solute? Well, a solute is a chemical which is dissolved in a solvent. And in chemistry, water is often used as a solvent. The unit of concentration for this definition is grams per decimeter cubed. A decimeter cubed is what used to be called a litre, but scientists don't use that word anymore. Now, we calculate the concentration using this equation. This equation is not in the spec, but I do think it's worth learning. The concentration in grams per decimeter cubed is the mass in grams divided by the volume in decimeters cubed. And here's a triangle to help you learn this. So let's look at a typical question. 200 grams of a chemical is dissolved in water to a final volume of 1 decimeter cubed. Calculate the concentration of the solution. Here's the equation. To find the concentration, we divide the mass in grams by the volume in decimeters cubed. This gives us a final concentration of 200 grams per decimeter cubed. Now, that was quite an easy one, so let's look at something a bit more challenging. 150 grams of a chemical is dissolved in water to a final volume of 0.5 decimeters cubed. Calculate the concentration of the solution. Pause the video and try this yourself. Okay, dividing 150 grams by 0.5 decimeters cubed gives us a final concentration of 300 grams per decimeter cubed. Okay, now in the exam, you could be asked to rearrange this equation and calculate the mass of a solute or the volume of a solution. So here's another question for you to try. Calculate the mass of a chemical needed to dissolve in a final volume of 0.4 decimeters cubed to give a concentration of 600 grams per decimeter cubed. Now, to answer this question, it's worth using the triangle. Pause the video and try this yourself. We're calculating mass, so we multiply the concentration by the volume. Multiplying 600 by 0.4 gives us a final mass of 240 grams. Here's one more question for you to try. Calculate the final volume of a solution containing 200 grams of a chemical with a concentration of 800 grams per decimeter cubed. Here's a triangle. Pause the video and try this yourself. Okay, we're calculating the volume, so we need to divide the mass by the concentration. 200 grams divided by 800 grams per decimeter cubed gives us a final volume of 0.25 decimeters cubed. Now, if you're a higher student, you need to be able to explain how the mass of the solute and the volume of the solution affect the concentration. Here are the two facts that you need to know. If we increase the mass of solute and keep the volume the same, then we increase the concentration. If we increase the volume of the solution and keep the mass of the solute the same, then we decrease the concentration. Remember that you'll find plenty more questions on concentration in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to calculate the concentration of a solution in grams per decimeter cubed, and if you're a higher tier student, you should be able to explain how the mass of the solute and the volume of the solution affect the concentration.